So again, we're starting Unit 4. This is 4.1.1, Applications of Probability. And actually, it's going to be later in the week and next week when we actually say, you know, the chances are it's a 15% chance of it happening, or it's a 1 in 5 chance of it happening. Okay, we're going to get into the actual probability and likeliness of events a little bit later. Before we do that, we have to talk about sets, which set theory is a whole branch of math. It has its own notation. It's different than what we've been practicing with the quadratics and different algebraic kind of approaches. Set theory is, and a set is, just a list of items. So, for instance, a set could have, you know, you're going to roll an even number with the dice, So a lot of what we're going to do today is rolling a die and seeing what the different sets and outcomes can be. Okay. So a set is just a list of items. And then here down, this is kind of like the hierarchy. On the very outside is the sample space, the universal set. So in the warm-up we did a Venn diagram with our birthdays, January through June, June through December. I put a U up in the top corner because this is the universal set. It involves everything. It involves all the subsets. So a sample space is, if I'm talking about rolling a die, the sample space, those are the numbers we can get. 1, 2, 3, 4, 5, 6, right? So a typical die, 6-sided die. The sample space is just including everything that you could possibly get. So we got 1 through 6. Pretty straightforward. A lot of what we're going to learn for this unit are things that intuitively you already know, right? So you don't know about set theory and probability yet, but how about the likelihood for rolling an even number with the die? What do you think? 50% chance, right? Half of them are even numbers, half of them are odd, so I'd have a 50% chance. So what I'm just trying to point out is the actual questions that are asked aren't super tricky. Some of the questions can be tedious, but the main thing that we're going to have to get used to is the set notation and all the different ways to. You'll see over here we get to a couple of new symbols maybe you haven't seen before. But we're talking about the sample space. That's the big picture. That's the big picture. Everything involved. The experiment is roll the die once. That's the experiment. Roll the die once. That's just what you're going to do. Okay. So like when you do an experiment, you're not even talking about the outcomes yet. Right? You're testing your spa for the acidity. If you're, like you all know how to do that and do that often. Let me see. If you're putting gas in your car, right? That would be the experiment. The outcomes could be you putting in unleaded, premium, or the ultra fuel, whatever. So basically, the experiment is just roll the die once. The outcomes or events are the things that I want to look for, the different ways that I can write what a set is included. So set A is going to be roll an even number. What goes in my set? If my sample space is 1, 2, 3, 4, 5, 6, what would go in my set for rolling an even number? What numbers are included?
2, 4, 6.
2, 4, 6. Easy, right? It's not a difficult question. It's just asking you, what even numbers could you possibly roll with this sample space. The notation, this bracket, if you don't know how to draw those, to draw big for you, it's basically, well, that's ugly. Oh, that's much better. We actually had it when we did systems of equations. It's the same bracket, but they go on both sides. And we're going to put all of the elements inside there. Okay, the other outcome that we're interested in, just like very basic here, is to roll an odd. What elements go inside that set B? Rolling an odd. All right, is there anything in common between those?
There's 3 of them.
There are 3, yeah. But these are exclusive events, or sorry, outcomes, because there's nothing shared between them. So there's nothing shared. Okay, so next what we're going to do is we're going to look at a couple examples at a time well, one at a time, but we're going to move through them together. And we're going to learn a couple of new definitions. So everything that I underlined in the first board over here, I want you to underline yourself. You need to underline, these are the phrases that it'll be helpful to have these kind of little examples here in this sample problem. So underline set, underline sample space, underline experiment and outcomes. There you go. The time change is messing with some people, I see. Nah. Okay, so the sample set could always be different. We're still dealing with the die, so it's 1 through 6. In the classwork and homework, sometimes there's sample sets 1 through 10, sometimes 1 through 20. So it's not always a die we're dealing with. Okay. If it was a deck of cards, how many elements would I have in that sample set? 52, not counting jokers, right? If I don't count them. So here we go. Here's our sample space. 1, 2, 3, 4, 5, 6. Event C with set C is going to have roll a number greater than 4. I want you to put what elements go in that set C if I'm looking for rolling a number greater than 4. Again, the question isn't the brain buster. The part that's tricky is set notation and what's coming next. All right, so if I'm looking to roll a number greater than 4, what do you think? 5 and 6. It's not greater than or equal, so we'll just put 5 and 6. Okay, that's easy, pretty easy. Set D has the event. Event D is roll a number less than 2. What goes there? 1. I see, I can tell. Seems too easy. So the event tells you what's going to happen, right? Here the outcome events for this situation was roll an even, roll an odd. Again, this experiment is rolling a die once. Sample space is everything that's involved, everything that could be included. All right. And then I'll give you a moment to start writing down example 2. Union is our main idea for this one. And I'll just talk about that a little bit while you're copying it. So in a union, we're looking for everything in both sets. So everything in both sets, if I'm looking at the Venn diagram here, everything in both sets is going to be everything over here in C and everything over here in D. It's going to be on both sides. Yeah, you can see that. And then the next thing is there's a notation for it. If I read this, it says the union between C and D. The union is everything in both sets, so when I go to this, I have to remember this little U is the new symbol for union we're going to be using. I like to think of like a workforce union. Like in our district, there's the Teachers Association, the union for all the teachers. So I teach math. Scavarla next door teaches history. But it doesn't matter what set we're part of, math department, history department, whatever. We're all in the same union. It's just everyone that's in the union, everyone that's included, everything. So a union is everything in between, and it has the union symbol, the U. So if I'm looking for the union between set C and set D, what should I put as far as my union goes? If up here is set C and here is set D. It's everything in both sets. So what should I put in my set right here? Yeah. Notice too, what kind of order did I put those in? Least to greatest ascending order. You're always going to put it in ascending order. And mostly because it makes it just easier to find the different elements quickly. If you have to search through and there's a one kind of hidden, it's not going to be helpful. All right, so union is everything in both sets. Venn diagram is everything in both of the circles, all the elements. And then the next one, let's get rid of this. All right. Example 3 is our new, the next term we're learning here is the intersection. The intersection. And it includes the elements that are shared, the elements that are in common. So in this case, for my Venn diagram, I'm going to go ahead and shade in between because it's the things in common. That's the intersection. I'm sorry, it's hard to see there in the back. It's the, let me read it, intersection, and I have in quotes here, elements shared. Elements shared. I have a set E. I'll read off the set. E is equal to 1, 2, 4, and 5. 1, 2, 4, and 5. Set F is equal to 1, 2. Actually, I'm going to make this 1, 2, 3, and 4. 1, 2, 3, and 4. And what I'm looking for now is the intersection, this symbol down. I think of it like a cup. A cup is going to get the things right in between the two. Okay. Up here, the union, just think everyone that's in the union includes everybody. But the cup is just going to get a few things, just get the things in common. So I need to find the intersection between E and F. So what are the things in common between E and F? Go ahead and fill it in your bracket, and then we'll look at that together. Intersection of E and F. All right. Okay, turn to your neighbor, make sure that you have the same values. What do you think?
No, I got 1, 2, 4, 2. He said that you got 1, 2, 4, 2.
All right, good. What goes in here, guys?
1, 2, 4.
1, 2, 4. Why didn't I put a 3 in there?
Because there's no 3 in both of them, and no number with no 5.
Correct, I think. So 3 is here, but 3 isn't here. So the intersection doesn't include 3. It just includes 1, 1, 1, 2, 2, 4, 4, 4. That's all. I know.
Yep.
Y'all got up way an hour earlier.
No,
It's okay. Daylight savings time.
damn, daylight savings time. I didn't get no sleep regardless.
Oh my. All right, so I'm gonna go ahead and move this over. Okay, and that's the best we can do. All right, here we go. All right, so we just learned union. That's everything in both sets. Intersection is just the elements that are shared, right, in between. Now we have complement. And this is denoted by this line above the letter. And it's not in the set. It's not in set, okay? It's everything not in set F. That's what this complement of F with the line above it. Complement of F with the line above it is everything not in set F. So I would look to see, okay, what's in set F? What was my sample space for starting? The complement of F is everything that is in the sample space, but not in F. So we have to look at that. And the way I'm going to mark this off as far as our diagram goes is it's basically everything that is not in F. So I just shaded everywhere, all around, but not in F. See? Even the parts that's shared with E is excluded because it's just everything not in F. So I look at this. Oh, I see a little message that says, "Happy birthday, Daniel and Omar." What do you know? I was going to do happy birthday at this point, but
We did it early because
we did it early. You're eager. It's my sister's birthday, too. What do you know? What are the chances? At the end of the evening, you'll know. Almost null. All right, here we go. So what is the complement of F, which says what elements are not in F? Let's look at F. 1, 2, 3, 4. My sample set space was 1, 2, 3, 4, 5, 6. So what goes in here as far as the complement of F? Go ahead and actually double check with your neighbor. 3 seconds. Go for it.
No, 5 and 6. You know what I'm saying? We had 5 and 6.
Wait, oh my gosh, wait, yeah. You have the door.
There you go.
Thank you. E, okay.
Got it? Oh, I see it. All right, let's see. Yanni, what'd you guys get?
5 and 6.
5 and 6. We look to see, perfect. We look to see what is in set F, right? We look to see what sample space we're using, 1 through 6, so 5 and 6 is what's left. Okay? So far, again, it's just the notation, the language we've got to get used to. All right, last but not least, and then we'll have a couple samples. Last but not least, the null set. This is like a 0, but it has a slash through it, which means empty set. It means a null set. It is when you have nothing in common. When there's nothing in common. There's nothing in common, or there's no elements at all to even write down. Which is nice. You don't have to write nothing in common. You make that empty set symbol, and that just shows there's nothing involved. Okay. So I look at my event G here. Event G is roll a 7. We're still using this sample space, which is given. Sample space is 1 through 6, so we're talking about a die. What elements go in set G, which is roll a 7? What goes in there? Nothing. So instead of leaving it nothing, it's a null set. So what should I put? Thank you. I try.
It's more than a 0. It's a no.
It's a null.
Just do it with the line to it. Technically, that.
All right.
Well, nothing more than 0.
Okay, we're still dealing with the die. Our sample space is still 1 through 6. The outcome we're looking for, our event is roll a multiple of 2. I want you to go ahead and put in set H the elements that are included in the event, roll a multiple of 2. And I said event or outcome because those are interchangeable definitions. All right, multiple of 2. We actually kind of did this on the other side, so I'll take it.
This is good old 2, 4, 6.
Good old 2, 4, 6.
Hey.
I have a country on you.
No, I'm thinking, for some reason I'm remembering that number and I don't know why. Oh dear.
Huh.
That'd be another case of deja vu.
Oh my. All right, maybe deja vu will help you answer this one. What's the complement of H? What is the complement again? Just checking. Complement?
Everything else.
Everything that is not in H. So what should I put? 1, 3, 5. Good. Remember, it's separated with commas. Remember, it's in ascending order, least to greatest. And finally, we have this. You didn't know this notation before today, but let's look at the two sets. We're looking at set H and the complement of H. We're trying to find the intersection. When I put a cup, I just take parts of each that are in common. So what is in common between H and complement of H? Isaac, you had a hand up.
No,
No, because what is in common between these two sets?
absolutely not.
Absolutely nothing. So we get the null set one more time. All right. So for you guys, I think, well, I think that I may just set you loose on the classwork. I was going to do a couple together, but we're good. Thumbs up, sideways, down for this stuff. Feeling pretty good. I see a lot of thumbs. Double thumbs up. Sleepy thumb up? Yep. All right. I'll do a shout out to all the birthday people today, all those that missed.
Yeah.
And to my sister's 41 today. Love you, Deanne. All right. What number gets free Oreos?
One.
I'm saying it again. 123rd gets Oreos. I think I'm in the 90s. The 90s.